All right, today we're going to explore how to compare data in SPSS by running our t-test and looking at the enrollment for two different regions in our data sample. So you can see here, we already have our data sample pulled up in SPSS, and we're wanting to compare region 1 to region 5. So when we're looking at this, because we're looking at enrollment sizes of the districts, when we're talking about our hypothesis or what we're looking at, our null hypothesis would be that there's no significant statistical difference between region 1 or region 5. And then our alternative would be that there is a significant statistical difference between region 1 and region 5. With this hypothesis, really, we're kind of looking at, are there anomalies or, are there trends or concerns that we're not aware of in kind of our regions? Or are things equitable and equal and we're doing great? So to look at this information, what I need to first do is limit my data that I'm going to have SPS look at. So I'm going to first go up to the main menu tabs up here and click on data and go down to select cases. So what I want to do is click if condition is satisfied. What that'll do is it'll allow me to limit data to just the conditions I want. So if this condition exists, I want you to look at this data. So I'm going to click on if, and I want to bring over the regions. So I'm looking specifically at the regions because it will include all of the different school enrollment numbers from the regions that I tell it to look at. So I'm going to bring over region, and I need to click equals 1. And then I'm going to click on this vertical bar button here and type in region equals 5. And that'll allow me to pull data from just those two regions specifically. So I can click OK and click OK here. And you'll notice when I scroll down to my data, it's hashed out or stricken from the record for right now. So that is good. And I'll just double check to make sure number 5 or region 5 is all good, and we are. So once I get there, I want to start to analyze my data. So I'm going to create my data analysis. I want to still find my descriptives and my basic statistical information that we need to look at. But I also wanted to create me a nice chart for my data, which will help us visualize and see if there are anomalies or a wide range of variance in the data. So I'm going to go over to Explore. And there's a couple things that I'm going to do here. So I want to have my data separated out by region again. So I'm going to bring my region into my factor list. And then for my dependent list, we're going to look at enrollment. So that means it's going to create me graphs and statistical analyses for each region based on the enrollment numbers. Before I get here, I want to click on plots. This will allow me to choose my descriptive type. So we're going to take off stem and leaf. We're going to click on histogram. Then I also want normality plots with tests. This will give me some other information about the variance. So it'll look at the specific information in terms of the comparison and let me know if there is just an assumption of normality, if all things are equal, or if we need to assume that there is a high level of variance. So we're going to click continue. We're going to click OK. It's going to bring me up into a new window, and you'll see I have my statistics here, which we'll go over in a minute, and then our histograms for region 1 and region 5. What I want to do now is I don't have my bell curves pictured on my chart, but that's an easy fix. All we're going to do is double click on one of the histograms, and we're going to go to the Elements tab, and we're going to have it show the distribution curve. So we want our normal distribution curve, and then we're going to have the parameters set to automatic, and it pops up already, so we don't need to do anything else. And you can see that I have my bell curve now on my histogram, and when I close out of this chart editor window and I go back and bring my data set up, you can see it gets brought up there. So we're going to do the same thing for region 5. We get our bell curve on region 5 as well too. So now I also need to run my t-test. So I have my statistical information. Now I need the comparison of region 1 and region 5, and really to find out what the variance and all the other things that we're looking at in terms of the validity of data, the reliability of data. So we're going to do that by doing a t-test. So I'm going to click in this window, I can do it, and click Analyze. and we're going to go to compare means and proportions. We're going to click on independent sample t-test. So again, I want to look at and have my data separated out by regions. And I want SPSS to look at just our enrollment information. Before we go and click on run, we got to do a couple of things first. So I need to define my group variables. So again, we have limited the data to just group regions 1 and region 5, but I also need to tell SPSS just to look at that data again. So I'm going to click and type in 5 for my group 2 value. That'll pull region 5's data because it's already set up that way in our data table. So I can click continue here. And then I'll click on options just to make sure that there's nothing else here I need to change. Nope, we're good. The only other thing before I run the t-test is we want the homogeneity of variance test also to be ran. This will allow us to look at the consistency or the uniformity of the variance in our data set. So we're going to click OK. We're going to run that test. And you can see here now we have some further information about comparing our statistical information here. So we're going to scroll back up to the top really quick because what does all of this now mean that we have all of our tests ran? So you can see here just in our summary, here's the sample size that we looked at. So region 1 had 72 schools, region 5 only had 23. So a little bit under for what you'd want for an appropriate sample size for the analysis that we're doing. But for region 1, you can see they had a mean or an average enrollment size of 2,353 with a median size of about 929. The biggest district in that region was 21,962, and the smallest being 342. And so when we go down and look at our standard deviation, plus or minus 4,000. So again, we're already kind of seeing a high level of variance there with just the standard deviation alone. And when we go down to region 5, average district size of 987 with a median size of 998. And so that's already kind of telling me that there's probably a few smaller districts or a large number of small districts compared to bigger districts in this region. With our standard deviation, we only have plus or minus 490, so not as much variance as region 1. But when we look at the minimum smallest district size, we have 343, and the biggest district size is 1,893. So region 1 already has a bigger, just a single district in their group. And then here's just our test of normality. And so we can already see that with region 1, with it being less than 0.05, we have a wide level of variance. And with it being 0.186 here, we have less variance with region 5. When we look at our histograms, you can see that, right? Typically with a bell curve, right, we want our bars of our histogram to be in line with at least the pattern of the bell curve. So they can go beyond the bell curve like you see here, but we'd want some of these other smaller bars to be closer to mirroring the level of the bell curve. And you'll see that better here on histogram 5. Where we start to have these nice, especially in the middle, we start to see some of the bars following the bell curve, but obviously here we have some of these outliers that are way beyond what we'd expect. And so you'd like to, see kind of your bars of your histogram follow the bell curve. And you can even tell here there is still some variance going on. When we come down to our statistics, again, it tells us here our mean, our average district size, the standard deviation, and then the standard deviation error mean is just on average. If there was an error, this is what we'd subtract from our standard deviation or add to our standard deviation just to make sure we're hitting that number correctly. And so you can see we have variance here. Before I jump into our independent t-test, I need to look at our homogeneity of variance test to see what row I'm going to look at. And so with our significance factor here of 0.011, that's going to tell me that I have a high level of variance because it's less than 0.05, or I'm going to have some more variance than I would expect. So I'm going to assume that equal variances are not assumed. So I need to take that approach. And so then what I'm looking at here is, again, my significance of 0.006. So what that tells me is that we have some difference between region 1 and region 5. They are not equal, there is not equity, and there's a wide range of variance between those two regions. And you can see here with my t-score, what that shows is that there's probably a good amount of difference in variance, so that T will show us that, again, we need to start rejecting that null hypothesis that there is more variance than we can expect. If, again, we had this smaller number, still slightly some variance, but again, because we do have more variance shown in our data set, shown in the histogram, shown by our significance here factor and our significance factor here, we do have variance that is present and is definitely noticeable. Lastly here, we want to look at our Cohen's test. So we have an estimator of 0.389, and that again just tells us that the variance is about a medium effect size. You can tell there's a noticeable difference. It's not a fluke that there's a variation in the data, but there's definitely something that needs to be looked at. And so when we go back to our hypothesis, again, we're looking at there being a significant statistical difference between region 1 and region 5, making us reject the null hypothesis. And that is how we can create some graphs in SPSS, some histograms, and run some comparison testing to figure out what our data is actually showing us. Thank you.